Good day, respected Dr. Raymond. I am Melviana. Today I would like to present my project, the Student Expense Tracker application. This mobile application is designed to help students manage their daily expenses in a simple, smart, and organized way. Many students often struggle to control their spending or keep track of where their money goes. Therefore, this application provides an easy solution by allowing users to record expenses, categorize spending, and monitor their budget in real time. The application is developed using Flutter and Firebase to ensure smooth performance, secure login, and cloud-based data storage. One of the main advantages of this system is that also support offline usage, which means students can still record their expenses even without internet access, and the data will automatically sync once connected again. In addition, the application is designed with a clean and user-friendly interface to provide a better user experience. To ensure software quality, reliability, and the system is also evaluated using GDVRR audit framework. Overall, this project not only helps students improve financial awareness and budgeting habits, but also demonstrates a practical and modern mobile application solution for everyday student life. Thank you.
Hi there. My name is Novlin, and I'm going to be the one to present GDVRR audit for authentication security module and number one, which is the construct, where I asked AI and I used Gemini. So I asked it to create a code or create multiple code for authentication. Okay, so I asked it to create a sign in and sign up page, and then it created this. So as you can see, um, uh, if someone user they register and sign in, it works perfectly and it sends back the string text success. But in number two, which is verified, according to the requests of human client, so they said that they wanted to be pop-up notification or error message if there's some error. And so for number three, I verify and I find what is the code anomaly keyword, which is generic error propagation, which is e.message, which is the last one in the picture. So this e.message, it is not specific enough to inform the user what kind of error is happening and what should be fixed in real time. Okay, so continue. For number four, which is rewrite, so I do the correction what should be put in the code. And so we know that in the old AI code, it said it used e.message for the notification at the pop-up to show the error, and it is not specific enough. So I changed the code so that it will show that okay, if the user it failed to log in, so what kind of error, whether their username, their email cannot be found, or their password is wrong, so the user will know and what they can change in the real time. So number five is reflect justification and algorithmic literacy. So why AI code failed in this case? AI it failed because it returned raw e.message, which directly links internal backend details straight to the mobile interface, but not specific, right? So, and human first principles, they evaluate the system's requirements from foundational ground rules, which is from multiple perspectives like data privacy, user experience, and others. And instead of taking guesses from e.message that pop up, the user will know what they must do to fix the specific error. Okay, thank you.
Hello, my name is Priscilla Lanja and my metric number is 100795 and my role is student B, which is focused on the code state management, the engine of the application. During the GDVRR audit, we found that the AI generated code used global variables and set state to manage expense data. This creates a state management anti-pattern because updates only affect the current pages and may lead to inconsistent data across different screens. To improve this, we propose using Riverpod as a centralized state management solution. Riverpod provides a single source of truth where all expense data is managed in one place and shared across the dashboard, budget, and history pages. As a result, all screens are updated automatically whenever an expense is added, edited, or deleted. This improves the data consistency, scalability, and maintainability of the application. Thank you.
Through the GDPR analysis, several improvements were made to the student expense tracker application to make it work better and more efficiently. The system now uses Firebase Firestore instead of temporary local storage, allowing data to be saved permanent online. Real-time updates were added using Stream Builder and Firestore Stream to make app smoother and avoid crashing during data loading. Input validation was improved using safer methods to prevent errors when users enter the data. The filtering process was also optimized using Firestore queries so the app only loads needed expense records, making it faster and reducing memory usage. In addition, the business logic was separated from the user interface using service classes to make the code cleaner and easier to maintain. Proper error handling was also added to manage database and connection problems. Overall, this improvement made the application more stable, faster, user-friendly, and easier to maintain.
Hello everyone, my name is Veronica Binti Antoni and my matrix number is 101271. I am responsible for the offline percentage and scenes module in our student expense tracker applications. This module is focuses on ensuring that students can continue using the applications even without internet connections, while also expense data even when the user is offline. The main goal of this module is first, to prevent data loss, and second, to allow offline expense recording, and synchronize the data automatically later. For human verifications, based on our interview findings, student request that the application should continue functioning even without internet access. User want to record expense offline, view their previous expense data, and avoid losing financial records during network issue. And therefore, offline support became an important requirement for the applications. Now I move to manual corrections. To solve this issue, we introduce Hive local storage, which is when internet connection is unavailable, the app save expense data locally using Hive. And when internet connections becomes available again, the application automatically synchronize the offline data with Firebase and Firestore. This improvement help prevent data loss and makes the application more reliable for daily use. Now for the synchronizations flow, this slide show how the synchronization process works. First, the user adds a new expense. Next, the system checks whether internet connection is available. If the internet is available, the expense is saved directly to Firebase Firestore. If the internet is not available, the expense is saved locally in Hive local storage. The two is a difference. Later, once the internet connections returns, the application automatically uploads the offline data to Firebase, and this ensures that all expense recorded remain safe and synchronized in the Firebase and Hive local storage. So that's all from my part. In conclusion, the AI generated code successfully implemented basic expense recording, but it did not fully consider real-life mobile usage when internet connection may be unstable. Human review was necessary to improve the applications by introducing offline percentage and automatic synchronizations using Hive and Firebase. These enhancements make the student expense tracker applications more reliable, scalable, and suitable for real student usage.
Hello everyone, my name is Jennifer Narichut and my metric number is 99267. So in this project, my roles focus on UI UX and asynchronous safety. So for my GDVR audit, I analyze the generated code that upload expense data into Firebase uh, and displays a snack bar notification. The problem is that Firebase operations are asynchronous. When the await keyboard is used, the widget may already be closed before the snack bar executes. However, the AI-generated code still uses build context directly after the asynchronous operations. This violates the Flutter asynchronous safety guidelines. So during the verification stage, I identified the anomaly as context degradation, also known as unsafe build context usage. So this is related anomaly asynchronous handling failure because the AI assumes that asynchronous executions will always complete while the widget remain active. So to correct this issue, I manually refactored the coding by adding the if context mounted return before displaying the snack bar notification. So this additional validation checks whether the widget still exists in the widget tree after the Firebase operation completes. If the widget has already been disposed, the function exists immediately and prevents unsafe build context access. This corrects improve application stability and ensures safer UI feedback during asynchronous Firebase operations. So for reflection phase, the AI-generated code successfully implemented the Firebase upload feature, but it is more focused on functionality than widget lifecycle safety. So these are two screenshots before and after adding expenses. So you can see that the money are changing, and you can see the remaining and expenses balance. And through the GDPR audit process, I improved asynchronous safety, UI reliability, and prevented potential runtime error. Overall, this audit shows that AI-generated code can work, but human review is still necessary to ensure safe and reliable application behavior. That's it from me. Thank you.